in one or more talk, right? Okay, so let's start with the second talk from Francesco, again from Sapienza, that will present a completely other vision of potential services interesting and emerging AI.
Okay, so thank you, Massimo. And just one request for Massimo. I need a picture of some slides for project purposes, okay. You know. So
no problem.
So, sorry for that.
Can you generate a synthetic?
Yes, of course. You will, everything that you will see has been generated synthetically. And now that the
photos.
Okay, yes, exactly. including photo, right? I don't know why I'm asking. So let me introduce myself. I'm Francesco Leotta. I'm an associate professor at the Department of Computer Control and Engineering of Sapienza University of Rome. And during this talk, I will introduce this new topic that we started recently. And we started recently means that we don't have yet, for example, a research contribution to present. So what we are going to present today is the idea that we have. So it's synthetic dataset generation as a service. So before going into the details of the topic, just let me explain you the context. The context is the context of the so-called AI factories. So what are AI factories? Basically are projects that have been funded by the European Commission across Europe. And actually these are national projects, okay? These are national projects funded by the European Commission. So basically every country in Europe has its own AI factory. And basically, what is an AI factory? An AI factory is a combination of an AI-optimized supercomputer. So the precondition to have an AI factory in EU countries is to have some kind of AI-optimized supercomputer, or more than one, and with the associated activities and services. So the idea is that every country creates a kind of ecosystem where you have at the center the AI supercomputer, and then the different partners develop services and processes that can help AI startups and the researcher, let's say, to keep the pace with the US and with China with respect to artificial intelligence. So basically, the idea is to support the development of European AI models and applications. And of course, as Italy, we have our own AI factory, which is called Italia. Okay. And these are the partners of the initiative. At the center of the initiative, there is Cineca, who owns the Italian supercomputer, which is called Leonardo. We have several universities and also other companies. And this is the infrastructure that is at the project. So basically, we have the supercomputer Leonardo, which is among, I think, the 10 most powerful supercomputers in the world. Leonardo was not originally intended only for artificial intelligence, because it also has a classical computing platform based on processor. Leonardo has been recently extended with these two other components, which are Lisa and Gaia. So Lisa is a new part of Leonardo, which instead is AI optimized. So it mainly contains GPUs, whereas Gaia is something that is intended to provide the cloud services, because the access to Leonardo is not through services, but basically what you do is that you rent GPU time, you connect to the machine, you do whatever you must do. Instead, this Gaia component here is intended to host cloud services, and one of the cloud services that it will host, it's the one that I am going to present in this presentation. Then we also have, and all of these three computers are placed in Bologna, And then we have this other supercomputer here, which is Megaride, which is instead in Naples, and it is part of the initiative as well. At the end of the project, we should also build a new supercomputer that will be called Italia. But at this time, this is not available. And this is the structure of the project, where Sapienza is involved on these three tasks here, which are synthetic data creation, which is the topic of today's talk. We are also involved in this task here, which is related to cybersecurity related services. We will also briefly talk about this. And then we have also this AI development thing, which is instead the goal of this task is instead to create new models, let's say. So, why synthetic data generation? Why do we want to generate synthetic data? Now, limitation of real-world data are well known and are discussed in several literature surveys. So, what are these limitations? There is a bias and lack of representativeness. You have a real-world dataset, and this real-world dataset has basically the same defects that the society has. For example, you have unfair, all the problem that we know, and we will discuss it about it later as well. Incomplete or missing data, noise and outliers, inconsistencies that are a lot. Temporal drift, because data changes over time. Usually the datasets that you can find on the internet only depicts the situation in a specific time. Class imbalance. This class imbalance is very important. For example, if you think about smart manufacturing application, for example, you want, for example, to create, let's say, quality control systems. Usually, in the vast cases, companies has a lot of examples of good products, and there's very few examples instead of products, which is a problem, because what you want to train is a system that detects anomalies and problems in products. This is a huge problem when you have to start up, for example, a project with a smart manufacturing company, and we will see an example later of this. Limited context. In many cases, you have that the real data only contain a subset of the features that are important to train something, and also privacy and ethical constraints, because data may be sensitive. For example, for this aspect, in the context of the project, we have a collaboration with the Italian Institute of Statistics that gather certain kind of statistics, and they want to anonymize these statistics. Of course, they anonymize it using classical statistical methods, but they are also interested in integrating these statistical methods also with the AI-based methods. So, when we talk about synthetic data, we talk about artificially created data that basically mimics the statistical properties, structure, or feature of real-world data, and it can be generated by generative AI models, which is nowadays is the main source, but also by using algorithms. And what are the goal of this synthetic data is to training and fine-tuning new models, validation of existing models, but also simulation of what can happen in reality. And this is the last point is very important, because when you generate synthetic data by using generative AI, for example, by using large language models, in the vast majority of cases, what you do is that you generate data with a powerful model, and this data with the powerful model, then you use it in order to train or fine-tune much smaller models that can be deployed, for example, on the edge and in the cloud. That's the main point. Just a comment about generation, because usually in this context you find two different terms, which are generation and augmentation. These two terms are different. Data augmentation in particular is different from generation, because basically in data augmentation what you have is that you have an original data set and you modify this original data set in different ways. We will see some examples according to the specific context, but the idea here is basically that you want to increase the dataset size in order to make models robust to variation. And so the key characteristics is that data augmentation, basically from the human point of view, doesn't introduce anything novel. It's more related to how training works how training works with standard AI models. And so what are the examples of data augmentation? You have, for example, you have a data set of images, and what you do is that you rotate, you flip, you stretch, you introduce some kind of noise, but again, you're always working on the same data set. Concerning text, instead, you take a text, you replace some words with synonyms from the so-called scene set. You do paraphrasing, etc. In audio, you can shift the pitch, you can stretch time, add some kind of noise. In time series, you can add scaling, jittering, etc. So the idea of augmentation, which is completely different from generation, and this is usually done through algorithmic means instead, and not to the generative AI, is that basically you increase the data set in order to model more robust. This is very frequent, for example, when you have an object detection, for example, model like YOLO, and you want to fine-tune YOLO for very specific application. That is something that is done very frequently, especially in smart manufacturing. So this is the framework we are defining in the Italia AI Factory project for dataset generation. So the idea is basically that we have a user that the system is intended to abstract all of the complexities that you have in dataset generation. We have a user that specifies certain parameters, and these parameters are, of course, the task of interest. The task of interest is what you want to generate. You want to generate a text, you want to generate question and answer couple, you want to generate classification data, you want to generate reasoning and planning sequences, multi-turn interaction, you want to translate thing, etc. Also, translation is a kind of dataset generation somehow. Maybe it's more related to augmentation, but somehow is considered generation. Then the user describe the domain. For example, I want to generate question and answer, I don't know, about painters of the 18th century or something like this. Okay, it depends on what kind of data you want to generate. This domain description can be also very, very complex. I mean, it could be a simple thing, but it could be also very complex. The user define an output template, and this is particularly true, especially when you think about generation of text. For example, I want the dataset to be represented in JSON using these specific attributes with these specific types, etc., etc. And then you can add, the user can add preferences. For example, augmentation of the dataset, anonymization of the dataset, class balance, unbiasing. We will talk about unbiasing later. The kind of generation strategy that you want to use, the format of the output in the sense of the type of the file that you want to generate, a Parquet file, etc. And then the user also select the model or the technique that he wants to use in order to generate his dataset. Here we have basically as models we have large language models, we have vision models, we have audio models, which are the ones that are currently supported by the system, even though we are going to extend it in the future. And also the user can provide optionally an input dataset, and we will see examples of when an input dataset is needed in order to do generation of new data. So all of these inputs goes into the dataset generation framework that we will describe later more specifically from the point of view of the software architecture. And what the dataset generation framework does is to generate datasets together with quality metrics, and these datasets can be used in turn into the dataset generation framework as well. All of the models that we generate here, because the dataset generation framework can generate datasets but also new models or fine-tuned models. The fine-tuned models can be used in a successive time in order to generate new data. So this is the idea behind. Okay, now we see some examples. So text generation. Text generation. You want to create realistic text. Now, text can be text in the sense that you have paragraphs that are written, but they can be, for example, question and answer couple. They can be tables, which is very frequent, because many times what you want to do is that you want to train, for example, credit score application. In that case, what you do is that you create tables where you have information about persons and whether they are getting the loan, for example, or they are not getting the loan. So tabular data is very important in text generation. There are several techniques in order to do that. And what are the common approaches? Of course, language models. That is, you use a language model, and what you do is that you ask the language model through a specific prompt to generate data in a specific format. Template-based generation, where instead you have I think it's a battery.
How we change it this morning?
Yeah, but they discharge anyway. I will keep it closer to my and template-based generation, where you basically have a template, for example, a template of an invoice or a resume, and what you want to do is that you want to generate data for this specific context. And finally, you have controlled generation, where you basically use any technique for generation in order to follow a specific style. So, what are the applications of text generation? You want to train natural language processing models without using sensitive text, for example. So, you perform generation for filtering and anonymization. You want to augment dataset for low resources languages, which are maybe supported by models. Generating dialogues for chatbots is very important, because AI models are frequently used for the development of chatbots nowadays. So, of course, generating tabular data, we already discussed about this. The dataset conversion task. You have a dataset and you want the task by doing for classification of the single items. Okay. And let's see a simple example. For example, here, this is an example I've done with a local model. This is a specific fine-tuning of Llama 3, which is an uncensored tuning. Uncensored models are important in dataset generation, because usually the models that you can find publicly are censored in the way that they are trained in order to avoid a certain answer on sensitive topics. For example, if you ask any kind of model for extraction on how to create a bomb, for example. Generally, what they do is that they refuse to do that, okay, because they contain. And there are a set of techniques that can be used in order to uncensor or to obliterate. This is the term the term that is usually in order to model creating uncensored data.
Go with your voice. And,
Yeah, but I'm not master. I will try to mimic. Okay, so as I was telling, basically uncensored models are a lot used in this context, because when you want to generate data, you usually do not want to be blocked by the natural guardrails that models models. So let's see this very simple example. Here, sorry, this is a little bit small, so we'll be this. So here my request was please generate a tabular dataset containing
Okay.
Okay, so
both. Something crazy. Go with the small voice.
So please generate a tabular dataset containing the following information: sex, income, country of provenance. In addition, the dataset should contain a final column saying if the person is liable for a loan or not. So this is what was the request. And the dataset generated is this one. Actually, the model added at the end a comment saying that the loan eligibility column is based on a simple rule that if the person income is above a certain threshold, in this case 6,000, they are eligible for a loan. Otherwise, they are not. So this is what the model is declaring. But if you look at the dataset, I mean, you can see, very explicit bias. For example, basically in the vast majority of cases, you have a male that takes the loan and a female that doesn't take the loan. Okay, and this is, this is a very trivial example. Now, this is a very small model. Okay, if you ask bigger model, in the vast majority of cases, you do not get these results. But this is to tell you that in general, when you generate data with an LLM. Generation is not that straightforward, because the model is not aware of the kind of bias that it has in general. Okay, so here he thinks that the bias is the income, okay, which is completely reasonable. But in the end, what happened is that the income on its turn is influenced by the sex. Okay, and this was difficult for him to understand. So a major challenge when we generate text data is fairness, okay? Because usually the data that you obtain are very low quality from the point of view of the fairness, and this is due to many different reasons. There are bias in the training data, which is of course what happens usually because these models are trained on the internet, and as we said before, the data that you can find on the internet, absorb what are the bias in the society. So what happens is that they learn some kind of correlation, even though they are not aware of that. Sometimes, of course, the problem is a matter of prompt, and this is even a bigger problem because we all know that a prompt that works with a specific version or over a specific model, it doesn't work with another version. So it's difficult to have results that are consistent over several execution. And there are also additional challenges. For example, when you try to generate very specific attributes, for example, official registration code is very difficult for the model to obtain codes that are realistic and do not have repetitions, especially when the generated data set is very. So what are the strategies that you can use in order to overcome this kind of problem? There are some naive strategies. One strategy is, of course, to improve the prompt. So you explicitly ask in the prompt to avoid certain kind of biases. This sometimes works, sometimes it doesn't work. So you can specify with the prompt, for example, that you want a uniform distribution across groups. You can specify that you have that the income is not important in order to decide whether the loan is given or not. That there is no dependence between ethnicity and credit decision. So you can modify your prompt in order to try to avoid this kind of problems. But in the vast majority of cases, you get very bad results. Okay? Because as I told you before, the thing is that the model is not really aware of all of the biases that you have, and many times you have a bias that influences another bias, and this is even more complex. Conditional generation. So basically in conditional generation, what you do is that you generate the first data set, and then you go value by value, and then you ask the model to generate more data by keeping fixed certain attributes, for example. You can do post-processing, that is, you generate the data set and then you solve the problem, the problems with some algorithmic post-processing. Now, instead, the advanced technique in order to solve this kind of problem is to use an iterative approach using auditing. So basically, you generate the data set, you measure some statistical quality measure of the data set, also from the point of view of the fairness. Then you use the result of the statistical analysis in order to drive the execution. For example, explicitly telling the system that to test the specific bias and to generate a new data set to solve that specific bias. And this works actually well, even though it's very expensive. The last thing is to use specialized synthetic data models, which is what we are going to see in the next slide. Before going ahead, I forgot to mention here, because we said about computing quality metrics, that there are several frameworks to measure fairness in data sets. And this framework here, which is the AI Fairness 360, this one includes a lot of different measures. This is a very well done thing, and this is what we're integrating in our system. So, using specialized synthetic data models. So this is an example using CTGAN. CTGAN stands for conditional tabular GAN. So this is basically a network structure that is intended to be trained to replicate some characteristic of the original data set. So basically what you do with CTGAN is that you have a small data set with certain characteristics. You train CTGAN, and then you use the trained CTGAN in order to generate the synthetic data set. This works very well, and then the most important thing is that it is very fast. Once you have the model, you can generate data much with an order of magnitude more faster than what you can do with a large language model. Of course, what is the disadvantage of this approach is that you are training this system, this model, so the data set that you use in order to train the model must be well done, because otherwise the model is trained with biased data. And here we have an example of application of this dataset generation, this textual dataset generation in the context of the project. One of the outcome of the project will be this framework here, which is called SEC Evalia. So what is the goal of this framework? The goal of this framework is basically to evaluate AI agents. The idea is that we give to Italian companies which are introducing AI agents at different level to test their AI agents against a certain set of risks. Okay, so ethical risks, but also more security risks, for example, related to the employment of resource-augmented generation for the data. For example, you don't want your AI agent to provide information about a specific person. And one of the, so basically how does this framework work very quickly? You have a data set of, you have a classification of the risk, and for each class, for each risk class, you have several examples of that specific risk. Then you have a set of generation strategies. In literature you can find many different ways of generating prompt in order to challenge the guardrails of LLMs. And at the end, you have a judge that tells you whether the attack was successful or not on your AI agent. And at the end, you get a report of what is happening. This is something we are developing, and Sapienza is part of it in the context of the project. But the important thing here is not this framework. It's about the fact that the vast majority of these techniques for analyzing the robustness of an AI models are language specific. And language specific means that in the vast majority of cases they are English specific. Okay, so if you have an AI agent, this AI agent is in Italian because you are creating something for Italian citizens. At that point, you need specific data sets, and you also need specific models to generate the attacks, but also to judge whether the attack was successful or not. And in order to do so, we are doing data set generation with the framework, because what we are doing is that we are starting from risk data set in the literature. For example, here you have a very common data set which is called harm bench. We translated ARM bench together with other data sets in Italian. Then at that point we used data generation in order to generate for each of the malicious goals that we have in the data set to generate safe and unsafe answers. We use a large model, for example, the open source version of GPT or Quen, in order to classify the answer. And then what we have done is that we have fine-tuned this Minerva model. Minerva is an Italian language model that has been done in Sapienza. So we created a fine-tuned version of Minerva for that specific task by using synthetic data. Then image generation. Another thing that you may want to generate are images. Now there are several different ways of generating images. Traditional one are generative adversarial networks, or to variational encoders. Now more recently diffusion models have become probably the best alternatives. You can go in the vast majority of cases, they are very big, so it is difficult to make them work locally. Anyway, the idea of image generation is that you create images to train some kind of system. And related to image generation, there is image in painting editing, where you not want to generate the entire images, but you have the images and you want to change only part of the image. And this is very important, for example, in the smart manufacturing scenario where you want to analyze the quality of the quality of products. And here we have an example. This is an industrial project we have been working on. Basically, it is a quality inspection system that checks the quality of cardboard. So you can imagine that basically a cardboard box is produced by inserting a cardboard rectangular sheet into a machine with cylinders, and the cylinders cut the cardboard and produce the boxes. Okay, and this is done for this kind of machine at a maximum speed of 3 cardboards per second, so very fast. And we have this camera here that is monitoring the area. Is monitoring the area of production, and through computer vision it analyzes the cardboard. Now, one of the problem that you have on this kind of, you can have several different quality problems on cardboards. You can have problems of size, you can have problem of cutting, you can have problems at bending, okay, because you have special blades that only creates the bends in the cardboard box. But you also have another problem that is a problem of cracks. According to the quality of the cardboard, what can happen is that the cardboard, while it is bended, it cracks. Okay? And this is a quality problem, and many customers do not want their cardboard boxes to be cracked. And whereas for the other things, we could use, let's say, algorithmic computer vision techniques. In the case of cracks, which instead are much more complex, we decided to train a machine learning model. And in order to do that, we do dataset. We did the dataset generation. So the idea is that we started from a few examples of anomalies. This means that we have, for example, an image of the cardboard, and we have human operators that takes, as far as I remember, we had 200 images, so something like this, so not too many, and manually check whether there is a crack or not. And the crack is labeled by using these white rectangles here. Then what we have done is that basically we have fine-tuned this Flux AI model, which is a very interesting model because it can do generation, it can do also in painting, style changing, etc. And in order to fine-tune this model, what we have done is that we augmented these data sets by providing a new version of these images where instead of the crack, instead of the defect, we basically modified the imaging by copy pasting parts of right bands. In this way, we have this report that is done by correct cardboard with defect, and where the defect is. So this was the training set, and then we added the textual description of the defect, and we use low rank adaptation in order to fine tune Flux. And we obtained this version of Flux. Basically, it was a fine-tuned version that was able to take good images of cardboards, which are the majority. Okay, and at that point, you are able to add this kind of defects. So at that point, in order to generate the dataset, what we do is that we have a much bigger dataset that is made up of products with no anomalies. Okay. And we randomly decide where to put the defects, and then we generate images of defected cardboard. Now, unfortunately, this is not very easy to see, but if you look at this band here it is correct, and here it is kind of deformed. Okay, so it is like a crack with and this is a way to use synthetic dataset generation to speed up the development of such models, which otherwise would be very difficult because in general, when you have companies, when you talk about defects, the percentage of defects that they have is very, very small with respect to the production. So it's very hard for them to provide you with training data. Okay? Maybe what they do is that they show you a cardboard, this is what you have to detect, and then and you tell them, I don't have any data to do. And here is the last component that we have already implemented in the framework, which is audio generation. So what is the idea of audio generation? Of course, is to generate, given a text or prompt, to generate some audio, which can be, for example, audio effects. Now a project that we are conducting here is a project for people with deaf disabilities, basically. So the idea is that what this user will do is that it has this device on his desk, and it can ask the device, for example, to train himself to recognize specific kind of sounds. Okay. And then what the system does is that it first generates the data sets for those specific kinds of sounds, and then it trains a classifier in order to understand that specific kind of sounds. And then you take the sound, you add some kind of augmentation by, for example, changing the pitching in order to reflect what happened, for example, when the sound is behind the wall, and that's the thing. So the idea is to create this device that can help people with deafness in order to have some kind of signal that something strange, And future generation, can you see? Oh, it's very late. Future feature, of course, video generation, time series and sensor data generation, 3D data generation, and multimodal data generation. We're not going into details of this specific thing. I cannot touch anything. So now, coming to the topic of the summer school, why do we want to servitize this synthetic data set generation? The first answer is straightforward. As I've shown you until now, all of these data sets are kind of very complex. They are not incredibly complex for a computer science, but of course they are complex for companies who has a limited notion of the office field. So the idea is to provide them with something that they can use just specifying some kind of configuration parameters. The other goal is to standardize quality and validation, of course, to lower the skill barrier. This is what we have already said, and to improve collaboration between non-technical and technical users, in order to put something in the middle, let's say, between non-technical and technical users. And what are the concept of the framework? Now we'll go into details of how the framework is servitized. Basically, we have this idea of jobs. We have two kinds of jobs that are generation jobs, that is, we want to generate data, and the training job, where you want instead to train a model that at that point can be used to generate data. We have seen some examples, for example, in the defect generation, or in the CT gun example, where you have first to train a model in order to generate the data. You cannot use the vanilla models in order to do that. And these jobs can be mapped either to Kubernetes jobs or to infrastructure as a code. This is the idea, so that you can either execute it immediately or give the user something that they can run on any cloud infrastructure. Collections of datasets. You have datasets that can be expanded. In the vast majority of cases, the collection of datasets only include a single datasets. The concept of model, of course, and the concept of quality evaluation, which is done using Fairness 360. And this is the architecture of the servitization. Then at the center, of course, we have a REST API, which is how the framework is accessed. Then we have a web UI with a command line interface that can access the REST API by using keycloak for authorization. And then what happens is that when you have a new job that is created by the user, this job is instantiated on Kubernetes as a model. Okay, So basically here we have training job. So for every training job, a new container, a new pod is instantiated. Generation job, for each generation job, a new pod is instantiated. This generation job can use either models that we have in the system, or they can use external APIs. For example, you can do the generation job by using the OpenAI API to access GPT. And all of these things have a resource layer. This layer that is basically made up by PostgreSQL, but any kind of relational database is okay for that, for dataset and model metadata, and S3 compatible object storage. At this point, we are using min.io. This is for application related to machine learning. This solution here, by using an object storage instead of the classical volumes, is a preferred architecture in the vast majority of cases. Especially because in this case you can decide at a certain point to remove your own object storage and move, for example, to cloud services such as Amazon S3 or things like this. And on this object storage, basically we have two different buckets, one for the datasets and one for the model. The dataset buckets includes datasets in the form of Parquet file, of JSON files, of directories of images. Whereas in the model buckets, we have the classical way of storing models. And so the idea is that in Postgres you keep only the metadata of the datasets in the model, and then the actual file are in the object storage. And the communication between all of these components is done by using Kubernetes secrets for communication. Now the alternative. I mean, this solution is good, for example, in our case, where we have both, let's say, the infrastructure to host the REST API and the computation infrastructure. But in other cases, maybe you don't have the computation infrastructure. So instead of instantiating these pods, what the REST API can do is that it can produce infrastructure as a code scripts in order to execute all of these things on another cloud infrastructure. And here we have just a few examples of the web application. Unfortunately, this is in Italian because the interface has not been translated yet. But here, for example, we have generation through LLM. In generation through LLM, we specify the task for which we want to generate data. The engine and the engine that we want to use in order to run the specific model, the AI model that we want to use, the domain about what we want to create the data, additional constraints for the generation, the number of iterations that we want to follow in order to remove bias, etc. Then we generate the dataset. We have similar screens for the other techniques. Here we have synthetic tabular data done using scan, image generation by using Flux, and here for each user we have the set of dataset that the user has generated with the possibility of expanding these datasets or to compute quality metrics by using these icons, these icons. So research challenges, which can be, because I mean, as you have seen, I mean, the discussion today has been very technical. As I've told you, we just started working on these things, so we didn't have any publication yet. But this is what we are working on. So there is this problem of turning the specification into datasets, which is actually unsolved. As this generation is very frequently based on prompts, and as we have said, prompts, I mean, the validity of a prompt can change in versions and models. I mean, a formalism must be defined in order to turn human written specification into more formal specification, and then at the point give a more consistent result. Also, the concept of realism is something that is unobservable, and in general it is a problem that is very badly defined, because when can we say that a dataset is real? Okay. Also for credit score, if I generate a dataset that is without bias, then is it a real dataset? Because at that point you can say no, it is not a real dataset, because a real dataset has biases. Okay, so I mean. You must define some kind of multi-objective definition in order to say what is realism for you. I mean, and this includes a reference to the final final unit. How to preserve in dataset generation causal rules? Okay, because in the vast majority of cases. Generation of course is statistical, so it doesn't preserve really causal rules, but only statistical rules. Composing different dataset generation step into a more complex dataset generation, and human in the loop specification and correction. And that's it for today's presentation. Thank you.
Questions that we can do now, and then in case they prosecute during lunch?
I have like tons of questions. That's why I would like to block one of the lunches or things with you to discuss it. But I just would like to mention that AI factory, which you mentioned for the Netherlands, is actually will be located in Groningen. And I must admit, I'll be a little bit behind in the planning and things and ideas. I will definitely would like to maintain a continuous connection, sharing experience, how to monetize it and how to.
You see, so the program has a rationale. I didn't know, but I do link prediction.
Yeah, Massimo always predict.
Good, very nice.
Victoria?
So you talked about in the dataset generation, like text, images, and audio.
Yeah.
And I think there is one other big class of dataset generation that you didn't directly mention is from different mechanistic models, right? So if you have like physics-based, chemistry-based models, and you can use those simulations to create a dataset.
Yes,
I don't know if in your framework.
Yes, actually, this is. I don't know if it completely fulfills this, but I mean, this is the idea of basically these two future features which are time series and sensor data generation. Where, as you can see, instead of using generative model, you can also use simulation. So this is one of the ideas. I perfectly agree with that. It's something we didn't work on, but it's something, of course.
Thank you very much for your talk. Just a similar question. You mentioned very different types of data you like to generate, but I'm missing business processes and event logs for processes. Are you working on that?
That's actually interesting. It's actually interesting because our group is working on business processes as well as in simulation. I have to say this is not my main my main thing. Actually, there is no explicit slice. I would say that this somehow goes also in these slides here. Okay. Maybe I should add that a specific part.
From my perspective, business processes and event logs for processes might have a very characteristic and maybe make it a special type of data. So
yeah, also it is a very active field of, and the vast majority of cases, simulation tools usually leave you always unsatisfied of what you obtain. Right?
I have a book chapter under review on using simulation for synthetic data generation of event logs. Yeah, for this BPM methodology, where Jana is probably published one too.
Yeah?
Thank you a lot for the great presentation. I generally very much like the use of synthetic data also because it's very available. So for the researchers, you need to invest let's say hours for finding the right data set. But for example, I had a problem with one vector, we could have regional availability for satellite data, so can be created a synthetic data set. So how would in a case where the number of synthetic data sets is skyrocketing, would you imagine some sort of, I don't know, standardized description that maybe can convince people that it's actually
Or standardized description, you mean not standardized format, you are talking about?
like in the sense of, let's say, how that it describes how the data was created basically. So can people
The provenance. You mean the provenance, the process of generating the data.
That's no, but this is something we didn't think about. It's actually really interesting. Yeah, definitely.
But this,
I
for
mean,
example, would make sense to join more universities that are behind to, if you say that bottom up, you start, this is important. Good call.
Thank you for the suggestion, because as I told you at the beginning, it's something we just started. So many of the things we missed, many of the things that would be interesting to do.
But I mean, as you mentioned, basically you cannot compare with ground truth. So how you have a lot of assumptions that you generally include, and then you have to document them somehow.
Yeah.
So
Yes, please.
Good question. So, in terms of applications, your data is you generate is mainly for simulation, right? Mainly for test things. You can't really do real decision making.
Well, I mean, this is a problem in general. I don't think this is a problem related to the dataset. This is a problem related to the AI models in general. Okay, because you train them, but in the end, they are. I mean, what I can tell you is that, and of course, it depends on the context because there are contexts. For example, I was talking with people in the military industry. Okay, and there was one guy who told me, but I cannot use an AI model to do that because I mean, if I'm in the military context, I want to. In general, I mean, depending on the context, you can use that. For example, looking at the example of the cardboard quality detection, what I didn't say is that what happened is that option, what the user can do is that they can decide to discard some item if it contains some problem. And this is a mechanical thing. So what happens is that the cardboard passes, you analyze it, and immediately the cardboard is discarded like this. And this is done based on these models. Of course, the damage if you do a wrong decision is not the time. But I think the problem is not with the data. It's more because real data set has the same problem. Okay? So it's and even worse because they are often very unbalanced.
The two items you have there, the financial application.
Sorry?
The financial application.
Yeah.
The application in the last slide.
Yeah.
Those are highly regulated.
Yeah. Of course.
I mean, anything synthetic, you can't actionably make. Like you can't take actions. You can maybe test your model. You can test some outliers. Test something that you want to test.
Yeah. I mean, I think that the point is really valuable. My impression is that, for example, if you look to China, as far as I know, in China they are introducing a lot in the hospitals techniques that are based on these kinds of things. Because in the end, I think that one of the errors that one can say is that, I mean, these models are not perfect, but in some cases, humans are not perfect as well. So you have a medical doctor, for example. I mean, medical doctors do mistakes. So I mean, why are we asking artificial intelligence to not do mistakes? The thing is the integration of the things. But anyway, I agree on the fact that there are certain contexts where you simply cannot do that because it's too risky.
I actually have one.
Last.
Yeah.
1 minute.
One query is that, like last year, I was working with this company called DBPAR, it's a next generation company in Germany, and we were building a model, AI model, to predict the incidents inside the factory, of their factory. And while we were using this synthetic data for predictions of severity of these incidents and what needs to be done according to that, while we were trying to convey the AI model to their main application, that this is the model that you can use them, there was a very specific requirement that what the parameters, how the parameters can be comparable regarding to this generation and the real dataset properties. So is there any kind of framework that is, because we are using these parameters to generate, right? So these parameters are these comparable to the real datasets properties? How is there any framework that is standardized?
I don't think so, especially because in the vast majority of cases, when you do synthetic dataset generation, you don't have enough real data. So comparing the real data with the synthetic dataset is unfair anyway, okay? Because, it is actually a good way. I don't, as far as, I mean, to the best of my knowledge, I don't know anything about this.
Big Bang said stop. So in 45 minutes, 43 minutes, we have to lunch. Changing your clothes, up to you, because we are getting in a very cold area, in a very hot area. So up to you, and jump on the bus. Do you come to the excursion?
My daughter.
Okay. So Francesco and Donatella are not sure that they will come to the excursion, but for sure they are here at dinner until Friday. So you have a chance to speak with them. Su questa no, fatti fatta adesso. Guarda.
I think it's more like an overview of how you can use things and what works around
Abbiamo scoperto Groningen, insomma, just Groningen è il fatto di cosa? Groningen è il fatto di Netherlands e Marco probabilmente la sua università non lo sapeva, è fatto della Germania, quindi abbiamo detto che noi dobbiamo sentire, fare un paper su come si fa tutto e poi se presentiamo un progetto lo devono sviluppare già è fatto, quindi non è proprio, quindi come di mission accomplished. Ok, where is the lunch? Because I invited the other but I don't know. Now, veloci. Hurry up. Allora, so before we go to change ourselves.
Generating textual stability is trying with the networkers and basically what the how is argument that we had research lab where we like try to they are being tried to generate